Dear students, in our today's class, we are going to discuss about the memory allocation of pointers. How memory can be allocated to the pointers, just like memory allocation of arrays and all those things what we have discussed. The same way, today we are going to discuss about the memory allocation of pointers. Memory allocation of pointers. Then how here memory can be allocated and what are the types of memory allocation under pointers? Come, we shall see now. The compiler allows the required memory. The compiler allows the required memory. The required memory space for a declared variable. Declared variable. Okay, here the compiler will allow, okay, the required memory space for a declared variable. It means when a variable is declared, at the time the compiler will allow its required space for that variable. And come now we shall see how this can be declared and in what way this can be declared. Take it as an example. For example, integer variable reserves 2 bytes. This means data type, okay, int data type variable, integer type variable, okay. So integer type variable reserves 2 bytes of memory. It means each variable of integer type will take 2 bytes of memory, and after this then next, first is integer, then float variable. Float variable reserves 4 bytes. Float variable reserves 4 bytes. And same way, character variable reserves 1 byte. Okay, integer variable means if we take the variable of integer type xy, this one variable of integer type takes 2 bytes of memory. Understood? And then float variable means if we have taken float p or q, this one variable can reserve 4 bytes of memory. Okay, and then if we take char name, okay, this is one variable and this variable reserves 1 byte of memory. Like this, memory allocation can be done under pointers, and this memory allocation of pointers is divided into two types of memory allocation. Come, we shall see which are these two types of memory allocations. therefore every data okay, and instruction that is being executed, data and instructions that is being executed what is meant by being executed here? Being executed, this means the data or instruction which is about to execute, not yet executed but kept for execution. So this type of data or instruction is called as being executed. Now about to execute, near for the execution, not yet executed, okay, to be executed. Understood? So this type of data is called as being executed. Okay, so for this type of data must be allocated some space. Okay, the data is kept for execution, and the data which is kept for execution, data or instruction which is kept for execution. So for this type of data or instruction, some memory space has to be allocated, okay, readily kept, and then where it should be kept in the main memory or the internal memory. Either the space should be kept in main memory or the space should be kept in internal memory. Okay, either the space should be kept in the main memory or in the internal memory. Either of these places, anywhere the space can be allocated for the data or instruction which are ready for the execution. And come, we shall see how many types of memory allocation is there. There are mainly two types of memory allocation. There are two types of memory allocation. Two types of memory allocation. Two types. Which are the two types? The first one is static memory allocation. Static memory allocation. This is the first type of memory allocation, and the next type is the dynamic memory allocation. The dynamic memory allocation. First one is static memory allocation. The next one is the dynamic memory allocation. So by this what we have understood? The thing we have understood here is the other things just like arrays, strings, characters and all, how they reserve memory, how memory allocation can be done in those things. In the same way, here in pointers also memory can be allocated, and it is also having a different type of memory allocation. And pointers, okay, the data or instructions which are ready for execution, for those type of data or instructions memory should be allocated, okay, and this allocation can be done under pointers in two types. One is the static memory allocation and the next one is the dynamic memory allocation. Now come we shall see what is static memory allocation. Okay, the first type of memory allocation, that is static memory allocation. Come we shall see how, what is meant by static memory allocation. Static memory allocation. Okay, under static memory allocation, how memory allocation can be done. In the static memory allocation, in the static memory allocation, the amount of memory which is to be allocated, okay, the amount of memory which is to be allocated, it is predicted and pre-known. Predicted and pre-known. Later I will explain you what is meant by predicted and what is meant by pre-known. And of this memory is allocated during compilation time. As I have told, the compiler can reserve memory for the variables used under pointers. If the compiler is allocating memory, then it means at the time of compilation only the memory should be allocated. And now all the variables declared normally, variables can be declared normally, are allocated memory statically. Okay, now I will explain you these things in detail so that you can understand clearly. Think that in the static memory allocation, okay, the amount of memory, think that we are having 1 GB of memory. This is the amount of memory we have with us. Then which can be allocated, no need to take which. Okay, yes, allocation in static memory allocation, the amount of memory to be allocated, right, to be allocated is predicted. Predicted means readily kept. Think that we are having two variables, they are of integer, one is x and another one is y. According to pointer memory allocation, okay, 2 bytes of memory is allocated for each variable of integer type. Then we are having x and y too. It means 4 bytes of memory has to be allocated from 1 GB. Here memory required is 4 bytes because integer type one variable can take 2 bytes of memory. But here we are having 2 variables, then it will take 4 bytes of memory. Predicted is from 1 GB of memory. Okay, this 4 bytes of memory is readily kept. And pre-known means, think we are having A, B, C, D, E memory locations. These are the memory locations. A, B, C, D, E are the memory locations. And these x and y, if they can be stored in B and C. Each memory location is having 2 bytes. Okay, this is 2 bytes. Okay, like same way, all are having 2 bytes only. Okay, then x has to be stored in B, y has to be stored in C. So here pre-known means in which place these variables are going to be allocated. So the name or the location of that memory is already known. Before allocation itself, the address or the memory location of the variables is already known. This is called as pre-known. Okay, it means x has to be stored in B and y should be stored in C. So the memory locations of x and y are already declared before doing allocation. So this is before storing the variables, the memory location of B and C are readily allocated. This is called as pre-known. Okay, then this memory is allocated during compilation time. While the program is getting compiled, at the time the static memory allocation is done, and then all the variables which are declared normally, all the variables which are declared normally, all the normally declared variables allocate memory statically. Only they will allocate, only their memory will be allocated statically. Hope you have understood after this detailed explanation. And come now, we are going to see the dynamic memory allocation. Now the second type, that is dynamic memory allocation. Dynamic memory allocation. Now we are going to see, before this we have discussed about the static memory allocation, and now we are going to discuss about the dynamic memory allocation. How memory allocation can be done dynamically. Come, we shall see this. In the dynamic memory allocation, and the dynamic memory allocation, okay, the amount of memory, declared is not known. So here, before this I have explained under static memory, that is the memory which is to be allocated is predicted and pre-known. Earlier memory is known earlier, but here in dynamic memory allocation, the amount amount of memory is not known earlier. It means before declaration, the amount of memory will not be known. If the amount of memory will not be known, then how the memory can be allocated dynamically? Come, we shall see here. This memory is allocated when it is allocated during run time as and when required. How the memory allocation is required? Based on requirement. Okay, the allocation of memory is done dynamically during run time. In static allocation, memory is allocated during compilation time, while in dynamic allocation, memory is allocated during run time as and when required, based on the requirement. And come, here mainly there are two operators. One is the new operator and another one is the delete operator. With the help of these two operators, allocation and deallocation of memory can be done dynamically. Okay, when we are using these two operators, that is the new operator and the delete operator, then at that time a separate memory location is needed by name, that is free pool. Come, we shall see regarding these three things. What is new operator and what is delete operator and what the free pool is called as. Come, we shall see here. C++ supports dynamic allocation and deallocation. Yes. Why? Because it is supporting static allocation, and the same way C++ is also supporting dynamic allocation as well as deallocation. And come, deallocation of objects using new and delete. I have told you that we are now discussing about new and delete operators. Allocation and deallocation can be done dynamically, but with the help of new and delete operators. Now we shall see how they work. These operators allocate memory for objects from a pool okay, called the free store. from this free store. Okay, memory can be allocated for the objects under dynamic allocation of memory. Okay, and then what are the uses of this new operator and the delete operator? Come, we shall see these two things. The new operator calls the special function, the new operator calls the special function operator, new. Okay, the new operator calls a special function operator new, whereas the delete operator calls the special, same thing, calls a special function operator, but not new. It calls the special function operator delete. Hope you have understood. Okay, new operator will call the special function operator new, whereas the delete operator will call the special function operator delete. These are the two uses of the new operator and the delete operator. Come, we will see in our next class how the new operator will work and how the delete operator will work, and along with that we will discuss in our next class the difference between static memory allocation and the dynamic memory allocation. If you have any doubts regarding these things about today's class, you can ask me personally. Thank you.